Welcome. In this video, we're going to continue to practice the integration by substitution technique. Let's begin by reviewing what we mean when we say substitution, or not really what we mean, but what we're looking for. And what we're looking for is a function composition, some function g of phi that's sandwiched inside of f, but more so, its derivative, g prime of phi, is multiplied here to the outside. So that's what we're looking for. So take a moment and look at this integral and see if you can find the function composition. Well, I see it right here. The outer function is e, so that's our f. The inner function is cosine of theta, so that's g. And now, is the derivative of cosine on the outside? Let's quickly review derivatives of trig functions, sine and cosine. I start by writing sine and cosine over and over again. And then I add negative to the bottom too. You might be asking, how does this help? Well, when we're finding a derivative, we go down in this direction. When we're integrating, we go up in this direction. So in this case, I want the derivative of cosine. The derivative of cosine is sine, but with a negative here. We're missing that negative, but that will come out in the wash, so to speak, when we make our substitution. What's important to know is that we almost have the derivative of cosine on the outside. So with that, let w equal cosine of phi, then dw equals negative sine phi d phi. So negative dw equals sine phi d phi. And suddenly, right here, sine phi d phi, that is negative dw. And then I'll have e to the w power, since cosine of phi is w. Rewriting this becomes the integral of e to the w times negative dw, which is just negative times the integral of e to the w dw. E, it's its own antiderivative, so this becomes negative e to the w plus some constant. And now I have to back substitute, of course, because I'm still in terms of w, and I don't want to be. I want to be in terms of phi because I started in terms of phi. So I end up with negative e to the cosine of phi plus c. Let's go ahead and check our work. I'm going to take the derivative of negative e to the cosine of phi plus c. This is the same thing as negative times the derivative with respect to phi of e to the cosine of phi plus the derivative with respect to phi of the constant of integration c. So I have negative, the derivative of e is e itself, e to the cosine of phi. Now I have to apply the chain rule since I have a function inside another function, and the derivative of cosine, as we can see here, is negative sine. The derivative of this constant of integration with respect to phi is 0. So I end up with e to the cosine phi times sine phi. And as you can see here, what we obtained in our check matches our integrand in our original problem, so we know our solution is correct. I hope this video was helpful.